Hey everyone, it's Mrs. Fallon again. I am going to walk you through how to graph a log function. All right, so a couple important things. First of all, main goal. Exponential functions are inverses of log functions. I just want to real quick kind of talk to you a little bit about what that means graphically. So if you remember our exponential function, it had a like a normal kind of, this is exponential growth, so it kind of crossed at the point 0, 1 with there's no shifts, had an asymptote at y equals 0, was an exponential function. If you go ahead and find the inverse, what you are essentially doing is reflecting that graph of this exponential over the line y equals x. So if you reflect it across this line, your result is your inverse. So I just kind of want to show you the log function. So because this exponential, a normal kind of no shifts, just plain exponential function has a starting or initial value at 0, 1, if you took the inverse of the point 0, 1, you would get 1, 0. And that's generally, without any shifts, where your log function is going to be. That's kind of where it's going to start. So another thing I want you to notice is that in a exponential function, you have a horizontal asymptote. In this case, at y equals 0, because we didn't shift it at all. In a log function, that translates into a vertical asymptote, but at x equals 0. So what this log function is going to do is it's going to kind of have a nice curve. So like think about how you would reflect this across the line, and it would curve like that. So that's the shape of a log function. And that's a log function that's just a normal log function, no shifts. The other thing I want you to be able to do is I want you to be able to think about, if I give you a function, what would the inverse of that function look like? So again, I want you to constantly think about the fact that an exponential and a log are inverses of each other. So here we start with an exponential function. Again, you can tell because there's no word log or natural log anywhere in this problem. It's a number raised to a power. That's exponential. So that means my log function, which is the inverse, would have to be a log with a base of 3, because the inverse of an exponential with a base of 3 is a log with a base of 3. So y equals 3 to the x, its inverse would be y equals log base 3 of x. So algebraically, that's kind of how you find like the inverse function. If this gets a little bit trickier, so like here, this is a natural log of x minus 3. This is your h value, kind of like you would with any other function that we've talked about, your h and your k. If you take this, so first I want you to recognize what's the inverse of a natural log. Hopefully you're remembering that's e. We're going to raise it to the x because that's our variable. And then this one had a shift of minus 3, which actually means it going right 3. But the inverse would mean it's doing the exact opposite. Instead of this being your h value, it's going to now be your k value. We're going to take the k value. So the inverse of that now becomes plus 3, because it's kind of going the opposite direction. So instead of going right 3, it's going up 3. So it's kind of like the inverse direction as well as the inverse, like instead of h, it's now k. So again, here's the shape of log functions. They're exact inverses of exponentials, and they all are kind of related to what we already know about exponentials. Let me show you how to graph a few of these. I'm not using a calculator on this, and I'm asking you to, I'm going to ask you to graph like 3 points on your grid, if you can. Sometimes these numbers get really big really quick, and so therefore you won't be able to plot them all, but you should be able to find a minimum of 3 points. All right. First, I want to talk to you about just all the letters. Make sure you understand where this is all coming from. If you remember, this is our initial value. So that's like the 1, 0, like on our graph from before, that initial point. And this is before any shifts. This is going to be your base, so the base of your log. This h value is going to be your right or left, so it shifts right or left. And that's pretty standard, what we've talked about before. But I also want you to remember this is now your asymptote. And the reason why is if you remember in exponentials, your asymptote was your k value. So in logs, it would make sense, since it's the inverse, it would be your h value. And then this k value, same as it does in every other function, it's your up and down shift. So again, very similar to what we've talked about with trig, as well as like cube roots and square roots and quadratics and so forth. All right, I wrote down some steps, so I'll have you guys, you probably want to take notes of those, especially put them in your comp book. Basically, these are just the steps I kind of follow to help me make sure I don't forget how to graph a log function. All right, so if you notice, my first step says plot the asymptote. So if I notice, my asymptote is my h value. So if this is my function, I don't have an h value, which means my asymptote is right at 0. Don't forget to label it as x equals 0. I do want to make sure that you know that that's what it is. All right, that was step 1, pretty easy. Next step, plot the initial value. So almost every log function that we're going to deal with doesn't really have a number in front of log, which means the initial value is 1, which is why we kind of always start right there at that 1, 0 point. Now, if there are any shifts, that's why I put like a little x here, because I didn't want to put a point because I haven't shifted it yet. But since this lovely equation doesn't have any shifts, I'm going to change this into a point because now I know that that's my actual point. So you start at that initial value, and then you shift it up, down, left, or right. All right, next, make a table. So what I want you to do for your table, most of us find it more challenging to come up with points when given a log function. So if that is you, which is probably going to be most of you, especially at the beginning, I want to challenge you to find points as an exponential function and then take the inverse of it. This is what I mean. So if I have this equation right here, this is my log equation. The exponential, or the inverse of that equation, would be an exponential with a base of 2. So what I'm going to do is I'm just going to find x and y values, like 3 of them, where I can I can easily raise something to a 0 power, 1 power, 2, stuff like that. It's a lot easier than trying to figure out the log, especially if I don't have a calculator. So for example, I'm going to start with 0, and if I raise 2 to the 0 power, I get 1. I'll go 1, so 2 to the first power is 2. I'll do 4 points. So 2 to the second power is 4, 3 to the second power is 8. So you can generate as many points as you want. I'm going to ask for a minimum of 3. All right, so next, we are now going to graph our log function, or find the table for our log function. So we're going to go back to our log function. So I'm going to ask you to remember all the way back to unit 1 of this year, which is basically asking you to find inverses of stuff. So if you remember, an inverse really just means, on a table especially, is you're literally just switching your x and y. So if this is the point 0, 1, on the log function that it's its inverse would be the point 1, 0. If I had the point 1, 2, it would be 2, 1, and so on down my list. So this is why I kind of start with the exponential function, because then the log function, I'm really just switching those around, and I don't have to really do any work to think about what the log is. Now, you're welcome to kind of skip this step and go right to here if that's something you're able to do, or maybe as you get further on in this, you're able to kind of skip that step. All right, so next thing it says take our inverses, which we just did, and then the last thing is to plot your points. So plot as many as you can. So we already have the point 1, 0, so 2, 1 is about right here. Again, we're estimating. And then 4, 2. All right, and what was the last one? 8, 3, 1, 2, 3, 4, 5, 6, 7, 8, and 8, 3. Remember, it has to approach your asymptote. It should be a curve, and that's what it looks like overall. All right, let me go through a couple other examples of graphing just to make sure you're good with it. Okay, I put 2 more on here, one with different kinds of shifts. So in example 15 that I'm showing you has a k value shift. So I just want to remind myself of those steps, right, to graph. So the first thing said plot the asymptote. So remember, your asymptote is your h value. If there was an h value, there would be parentheses, kind of like this one, and it's attached to the x, like it'd be an add or subtracted. So this one has no h value, which again means that my asymptote is at 0. Okay, next, I'm going to go ahead and plot the initial value. So in this case, I'm going to start that 1, 0, because remember, there's no number in front of log. Most of the time it's not. And then I'm going to shift it. So I put an x here. This -1 means I have to shift it down. So the point I'm actually graphing is this one right here. Okay, next. Make a table and take the inverses. So again, what I did is I started with My inverse equation, so this would be a log with a base of 3. I want an exponential with a base of 3. This one had a k value of -1. I want an h value of +1. So again, completely opposites. I'm going to generate a table. So I get, let's start with -1, because -1 would be an easy one for me, because -1 plus 1 is 0. 3 to the 0 power is 1. I can plot the point 0. 0 to the first power is 3. And I can plot the point 1. So if x is 1, I get 3 to the second power, which is 9. Now, obviously, you can find more, but you don't have to. All right, let's go ahead and take the inverses. So now this is just for our log function. Whoops, I'm supposed to say 3 there. All right, so I'm just going to switch those points around because that's how you find the inverse. All right, this is the point 1, -1. So remember when I graphed this? This is 1, -1. That was that first point on my table. So I did that already. Next one is 3, 0, which is right here. And then 9, 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 1. So what you will notice is I get a curve that looks something like that. Okay, let's do some more. All right, next one, the last one that I'm going to do has a h value of -2. So again, that's going to change my asymptote. So my first step is to find or plot the asymptote, which is my h value. So -2 means if I normally have my asymptote at 0, -2 means I'm going to shift it to the right 2. So just like you would shift every point to the right 2, the asymptote gets shifted to the right 2 as well. So I'm going to draw in that asymptote, and I'm going to label it as x equals 2. Next, start with that initial value. So again, starting with 1, 0, and then apply your shifts. So this again says right 2. So 1, 2. So this is the point I care about. So this is at the point 3, 0. So I started at my initial value. I shifted it right 2. All right, let's go back to our graph, or go back to our table. So this is a log with a base of 5. If I wanted to graph, or if I want to find a table for this, I might do an exponential with a base of 5. But instead of having an h value that's -2, it'd be a k value of +2. So again, opposite, like that. And now I'm just going to find some points. So again, I'm going to start with, I started with 0. I think that's probably the easiest. So 5 to the 0 power is 1. 1 plus 2 is 3. I'm going to go right in order. So I'm going to go 1 and then 2. So if I have 1, 5 to the first power is 5. 5 plus 2 is 7. And you can see this was going to get pretty big pretty quickly. 5 to the second power is 25. 25 plus 2 is 27. So those are going to be a little hard for me to graph. So I'm only going to graph actually 2 of these points, but I can still find all 3 of them. All right, so go back to my graph. This is the point. Oh, forgot to take the inverses. All right, so for my log function, log base 5 of x minus 2, my inverses would just literally be switching your values around from your table. So I plotted the point 3, 0 already. Let's do 7, 1. So 1, 2, 3, 4, 5, 6, 7, 7, 1, and then 27, 2. What this basically means is this graph is going it's real kind of shallow. I'm only going to be able to graph those 2 points, but that's okay. All right, folks, that's how you graph log functions. Hopefully that helped. Again, tune in for other, if you have questions, tune into the office hours from your teacher. Thanks.